Hello students, once again you're welcome to hello students, once again you're welcome to Waidsum Academy. Today we're looking at chapter 17, chemistry of the environment. Chemistry of the environment. In chemistry of the environment, we'll be looking at water and we'll be looking at air. So we want to look at water and air. So we start with the first one. We started with water. So the chemical test for water. Now, what is the chemical test for water? Anytime we want to test for water, we use what we call a compound called cobalt 2 chloride. We use a compound called cobalt 2 chloride. And anytime we add water to cobalt 2 chloride, you know cobalt 2 chloride is blue. Okay, the color is blue. So anytime we add water to cobalt 2 chloride, it will turn pink. It will turn pink. So cobalt 2 chloride plus water, cobalt 2 chloride plus water, we produce the anhydrous water, cobalt 2 chloride, right? So this test is usually done using cobalt 2 chloride paper. So we use the cobalt 2 chloride paper and then we dip it in water. You know, cobalt 2 chloride paper, which is blue, we dip it in water and then it will turn the color to pink. It will turn the color of the blue cobalt 2 chloride paper to pink, the part that has touched water. Okay, so this is what we have. Say the equation for the anhydrous cobalt 2 chloride reacting with water, we produce the hydrated cobalt 2 chloride. We produce the hydrated cobalt 2 chloride. Hydrated is this one. Dot 6H2O, cobalt 2 chloride dot 6H2O. This is called the hydrated cobalt 2 chloride. So, and the color change is from blue to pink. Look at it. Look at the reaction. This is a trough of water or a basin of water, and you dip a cobalt 2 chloride paper, which is blue, into this water, and you see the part that has touched the water begin to change to pink. So this is the test for water using cobalt 2 chloride paper, and which eventually turns to pink whenever it's dipped into water. Okay, so this is how we test for water. This is how we test for water. Yes, this is how we test for water, right? So we say in testing for water, we take cobalt 2 chloride. Cobalt 2 chloride, let's write the chemical equation. Cobalt 2 chloride react with water. Cobalt 2 chloride plus water cobalt 2 chloride plus water, H2O, we produce what? Okay, this cobalt 2 chloride is anhydrous. It's anhydrous, okay? So if reacts with water, become hydrated. It will become hydrated cobalt 2 chloride. So this becomes hydrated cobalt 2 chloride. Hydrated cobalt 2 chloride dot 6H2O. And the color change from blue to pink. Color change from blue to pink. So this one, the color is blue. Let's look for any blue. Okay, this blue. So when it's deep in water, this cobalt 2 chloride, we use the cobalt 2 chloride paper. Okay, we use the cobalt 2 chloride paper. Color changes from blue to pink. Here, over here, we have the pink. It changes, the color of this one becomes pink. Changes to pink. Okay, changes to pink. So this pink, this is the test for water. So anytime we want to test for water, we need what we call the cobalt 2 chloride paper, and all we need to do is just to dip the cobalt 2 chloride paper in water. To dip the cobalt 2 chloride paper in water. All we need to do is just to dip the cobalt 2 chloride paper in water, and we write the state symbols. Let's put the state symbol. Cobalt 2, this one is, water is liquid. This is solid. Cobalt 2 chloride is also solid, right? So these are the state symbols. These are the state symbols. These are the state symbols. Okay, so just taking the cobalt 2 chloride paper, dipping into water is just the test for water. It's just the test for water. The color will definitely change. Water will change the color of blue cobalt 2 chloride paper to pink. Now use copper 2 sulfate. So not only cobalt 2 chloride we use for carrying out this test, we can also use what we call copper 2 sulfate to test for water. So in this, we take the anhydrous copper 2 sulfate and it turns white to blue. The anhydrous copper 2 sulfate, the color will change to blue from being white to blue. Anhydrous copper 2 sulfate turns white to blue on the addition of water. So when you add water to copper 2 sulfate, it will change from white because anhydrous copper 2 sulfate is white. When you dip it in water, it will become blue. It will become blue. It becomes hydrated copper 2 sulfate. It becomes hydrated copper 2 sulfate. So let's take a look at that. So the test for water is not only using cobalt. The test for water is not only using cobalt. We can also use it. So the first one is using cobalt. The second one, if we're testing for water, the first method is to use cobalt 2 sulfate to test for the presence of water. Okay? To test for water. The second method is copper. The second method is using copper 2 sulfate. But anhydrous copper 2 sulfate, okay? All anhydrous. So we say the second method is copper sulfate, copper 2 sulfate. Okay? Copper 2 sulfate. Copper 2 in Roman figure. Copper 2 sulfate. So the second method is to use copper 2 sulfate to test for the presence of water. It will change anhydrous copper 2 sulfate, white anhydrous copper 2 sulfate to blue. Okay, for this second test, it will change it to blue. This is cobalt 2 sulfate as well. This test number 1 is using cobalt 2 sulfate, and test number 2 is using copper 2 sulfate. When we use cobalt, it changes from blue to pink. It changes the color of water of the cobalt paper from blue to pink. But when we are using copper, it changes the color from white to blue. It changes the color from white to blue. It changes the color from white to blue. Okay? So let's write the equation for this one. Number 2. Let's write the equation. Anhydrous copper 2 sulfate, react in water, dip it in water. Anhydrous copper 2 sulfate, CuSO4. Anhydrous copper 2 sulfate. React with water. Anhydrous copper 2 sulfate react with water. 5 molecules of water. We'll get hydrated. We'll get hydrated copper 2 sulfate. We'll get hydrated copper 2 sulfate. We'll get hydrated. Hydrated means now with water, with the presence of water. When you say hydrated, when you say dehydrated, meaning it's like there's no enough water in my body. So when you say I'm very hydrated, meaning you have water. So meaning this has a lot of water now because it's deep inside water, and the color change will be from white. Okay, from white, we can't write with white. From white color to blue. From white color to blue color. Okay. You know this because enough. I just wrote white with white color. From white to blue. The color change will be from white to blue. So this is the second test for water. When this happens, when you take copper 2 sulfate and dip it in water, and you get it, the color changes, the color of the copper 2 sulfate changes from white to blue, then there's that what you've tested for is water. Okay. Copper 2 sulfate is solid, water is liquid, as you know, and the copper 2 sulfate, hydrated copper 2 sulfate, is also solid for the state symbol. Okay, this is what it is. We suck the copper 2 sulfate. We have copper 2. This is a pipette. Okay, we suck water. We suck water, and then we drop the water in this beaker. This beaker containing white. You can see this white, right? There's white solid anhydrous copper 2 sulfate. There's white solid anhydrous copper 2 sulfate, and we've used this pipette. This is a pipette. Sorry, not a beaker. This pipette. We use it to suck water. Okay, and then we drop the water in this anhydrous copper 2 sulfate. This white anhydrous copper 2 sulfate, and you see the color changes. The color starts to change. The anhydrous copper 2 sulfate become hydrated copper 2 sulfate. Become hydrated copper 2 sulfate, showing the presence of water. So we say test for water using anhydrous copper 2 sulfate, which turns blue in the presence of water. So these are the two tests for two methods we can easily use to test for water. Two methods we can easily use to test for water. Now let's take a look at the purity of water. Let's quickly take a look at purity of water. How pure water is, or what is pure water. Testing for purity. Pure substance melt at their normal melting point, and they boil at their standard normal boiling point, specific value, sharp. Okay, when they get to, let's say melting point is 0, melting point of water is 0, of ice is 0. If it's pure, it will melt at 0 degrees Celsius. And the boiling point of water is 100 degrees Celsius. It will boil at 100. When it gets to 100, it will boil. So purity. When you talk about purity of water, pure water we boil at 100. We boil at 100 degrees Celsius, and the ice form will melt at 0 degrees Celsius. We melt at 0 degrees Celsius. Purity of water, or test for purity of water. Test for purity of water. Okay. Now that's the first point to know. Water has a boiling point of 100 degrees Celsius and a melting point of 0 degrees Celsius. Now mixtures have a range of melting and boiling point, as they consist of different substances that melt or boil at different temperatures. So if the water is not pure, it will definitely not boil at 100 degrees Celsius, or definitely not melt at 0 degrees Celsius. So when water is boiling exactly at 100, you know that water is pure water. If it's boiling above or below 100 degrees Celsius, it means that it's not a pure water. It needs to be purified. Melting at boiling points data can therefore be used to determine the purity of water. If you want to know whether water is pure, you have to test their melting point and their boiling point. Okay, impurity tends to increase the boiling point of water, so impure water will boil at temperature above 100 degrees Celsius. If impure water will boil at temperature above 100 degrees Celsius, because the impurity tends to increase the boiling point of water. Impurity tends to decrease the melting point of water. They decrease the melting point of water. So if you have water that is not pure, it will definitely melt at temperature below 0 degree. Below 0 degree means negative, minus 5, minus 2, minus whatever, minus 10. These are temperature where below below 0 degrees Celsius. So impure water, or water that is not pure, will start to melt at temperature below 0 degrees Celsius. Okay? Then if another testing ground is the boiling point. So for boiling point, impure water will begin to boil at temperature above 100 degrees Celsius. They will definitely not boil at 100 degrees Celsius. So these two scenarios, they're used for testing for the purity of water. They use for testing for purity of water. Now let's take a look at distilled water. Distilled water is water that has been heated to form a vapor, to form a water vapor, and then condensed, like cool. You heat it to temperature above 100 degrees Celsius, and then allow to cool back to a liquid again, because you heat it to become a gas, a vapor. Water that you heat to become a gas and eventually you allow it to cool down is called a distilled water. So if you remember distillation method in chapter 2 of in your chemistry, we boiled mixtures, and when we heat mixtures, they start to boil at their boiling point. For example, a mixture of water and alcohol. You know, alcohol boils at 78 degrees Celsius and water boils at 100 degrees Celsius. So when you heat this mixture, at 78, alcohol will begin to evaporate in the mixture. Alcohol will begin to evaporate and will be collected and condensed with a different beaker. When it gets to the temperature gets to 100, we take out the beaker for alcohol and we put that to collect water at 100 degrees Celsius. So in summary, distilled water is water that has been heated to form vapor, water that has been heated to form vapor, and then eventually cooled down for use. Cool down for use after it has been. So you see, in some homes, they boil water before they drink the water. So the water they boil and they allow it to cool down before they drink is called distilled water. It's called distilled water. Distilled water is the water that has been boiled to form a vapor and then condensed back to liquid. It contains very few impurity because probably the heating has killed some of the impurity. Okay, especially if you distill and filter it, you mostly remove the impurity. So it contains very few if there's any, very few if impurity. Distilled water is used in practical chemistry because it has a very high purity level. So when we're doing chemistry and we're doing experiment with water, we normally use the distilled water because it contains very little or nothing as regards to impurity. So there we say tap water contains more impurity. The tap water in your homes, in anywhere, in public place that has not been heated, contains more impurity. Okay? And could interfere with the chemical reaction, so it's typically not used. That's why in most developed countries, the tap water in your homes, they're not drinking water. So we found alternative way to get pure water or distilled water for drinking. So distilled water is more recommended for drinking than tap water. Tap water is full with a lot of impurity. Is that okay? Okay, now let's take a look at this section quickly. Let's take a look at the subsection 2, substances in water from natural sources. Okay, substances in water from natural sources. Now we say we use water in many aspects of our everyday life, right? Every day we use water for cooking, we use water for bathing, we use water for washing plates, we use water for washing clothes, we drink water, we use water to produce electricity in power stations. We use water for so many things, to mop the house, for mopping the house, for cleaning, for washing our cars. We use water for so many things. There is no life without water. If the water is taken away from us, then everything will shut down. Okay? We can't survive. Our body system needs to be hydrated. we have to keep being hydrated. Our body system needs to be hydrated, meaning we need to drink water constantly and continuously, okay, in order to stay alive. So we cannot do many things without water. We even use water to do irrigation for farming. We use water for farming because sometimes there are no rains or no enough rains. We water the soil so that our plants can grow or do better. We use water in the industry. Most of the machines in the industry, they use water. Even our cars, we put water in the radiator to cool down the engine. There's water in the radiator to continuously and constantly cool down the engine. So water has enormous uses, and its significance cannot be overemphasized. We cannot just say everything about water. There's so many benefits with water. If you have problem with breathing, drink a lot of water. Okay, so water can even help in the respiratory tract and respiratory system. So water has so many enormous uses. It is also used as a solvent. Water is used as a solvent to dissolve or to melt solid, to dissolve other solids. So it's so practical. It's used as coolant. I've mentioned this. It's used as coolant to cool down the engines. Okay, it's used to make electricity. We've mentioned this. So for domestic, we use water for drinking, for cooking, for gardening, and for general sanitation, for cleaning and all of this, and washing and all of this. In agriculture, we use as drink for animals. We use water to feed our animals. We give them to drink, and also for watering our crops and do irrigation purpose. In industry, it's used as solvent, used as coolant, and heated to make steam, and that we use to generate electricity. You know, it is the steam we use to drive the blades of turbines in electricity, in making electricity in the power station. And it's water we heat to generate steam. So we heat water, we get the vapor, we get the steam. That steam is a force, and that force, when it hits the blades of turbine, it turns the blades of a turbine. These turbines are connected to the rotor of a generator. So electricity is produced in power station as such. Okay, so water is found in natural sources such as in the lake, where we find water. We find them in springs, we find them in rocks, we find water in the streams, we find them in natural sources, in lakes, in rivers, underground. We find water in underground. That's why we can sink borehole and we get water out of the ground to power our homes and to power whatever we want to power. So you find water underground. Water sources like the groundwater also. We have water in the ground, running in the ground, as small streams or whatever it is. A rock that stores water is known as a aquifer. You know, aquatic, anything aqua is water. Aqui. Okay? So rocks that store water, they are called aquifer. You can find water in the rocks. And these rock waters, they're usually pure waters. Okay? Water from natural sources may contain varieties of different substances, such as dissolved oxygen. Water always have oxygen, right? Water, dissolve oxygen in water, metal compounds sometimes in water, because the water is running in tap. You can find some metal compounds in such water. They may not be conspicuous enough for you to see, but they're there. You can find plastic in water, maybe water in the rivers. You can find plastic in the broken plastics and all of this. Sewage dumped in the rivers, and you can find in the water. Harmful microbes can be found in water that is not clean. Nitrates from fertilizers that have been dumped in the river can be found in water. Phosphates from fertilizers and detergent can also find their way in water. When this is in water, they are considered to be such water is considered to be impure water. Okay, it's not pure water. Now, many of these substances they enter water sources when rain falls and washes them into the lakes. Okay, all these things when rain falls. Sometimes rain wash out some of these substances we mentioned, like sewage, into the rivers, harmful microbes into the river, nitrates into the river. The fertilizer you put in the ground in your soil to make your crops grow, rain and erosion can wash them down to the rivers. Nitrates from fertilizers can be washed down to the river when rain falls. Okay? Now let's take a look at the beneficial and the harmful substances in water. Some of the substances which may be found in natural water sources are beneficial, while others are very harmful. Now let's take a look at the beneficial one. The beneficial substances that find their way to water is one of these is the dissolved oxygen. Dissolved oxygen is essential for aquatic life. So it's very, very safe. It's very, very useful. And then metal compounds, some provide essential minerals which are necessary for life, such as calcium and magnesium. So when calcium and magnesium find their way to water, then this becomes useful to human existence. The harmful ones includes also metal compounds, which some of them which are very toxic, like the aluminum, like the lead, like the zinc. All these ones are toxic. When they find their way into water, the water become polluted water, to no longer be safe for consumption. Like some plastic also, broken tiny pieces of plastic are harmful when they find their way to aquatic water. Okay, they get trapped in the waste, and this can cause a lot of harm in our body. Sewage contain harmful microbes, and they can cause diseases when they find sewage water find its way to the natural water. Nitrates are phosphate from fertilizers. This one can promote the growth of aquatic plant life, which leads to deoxygenation in water. Like algae can start to grow, and also when algae grows, it covers the surface of the water, so the water do not get oxygen in it anymore. Oxygen do not get into the water anymore, so this could be harmful to us. Okay, so let's still take a look at one more aspect of this, and then we will be done for today. Water treatment. Now, before we continue water treatment, let's take a look at this tutorial before we continue on the water treatment.
In this video, we are going to look at the treatment of water. Water supplied to our homes is taken from rivers and reservoirs, so needs to be treated to remove impurities and kill any bacteria. The first step in this process is to filter the water to remove large insoluble solids. The remaining water is then pumped into a sedimentation tank where solid particles of mud, sand, and other substances will fall to the bottom of the tank due to gravity and form a layer known as sediment. The top layer is further filtered to remove smaller solid particles, and the water passed through carbon to remove any taste and odours. The final step is to add an appropriate amount of chlorine to the water, which will kill the bacteria. The amount of chlorine added needs to be controlled carefully, as large amounts of chlorine are toxic. The water is then stored in a storage tank until it is ready to be pumped to homes and factories. As well as being able to describe this process from start to finish, you must be able to explain why each step is done. This question asks you to explain what happens during sedimentation and is worth 2 marks. Remember, sedimentation occurs when particles fall to the bottom of a tank as a result of gravity and form a layer of sediment. Explaining this will score you 1 mark. Before this, you need to explain that water has been pumped into the tank and allowed to stand. If you have not allowed the water to stand, then sedimentation will not occur. This question asks you to explain why the amount of chlorine in a swimming pool should be carefully monitored. The question is 2 marks, so the best way to approach it is to think about what happens if too much or too little chlorine is added. The main purpose of adding chlorine to water is to kill bacteria, so you must add enough to ensure that this actually happens. Too little chlorine will not kill all of that bacteria, will score you 1 mark. However, as discussed before, too much chlorine would be dangerous because it is toxic, which will score your 2nd mark. In summary, water from rivers and reservoirs needs to be treated to remove impurities and bacteria before it can be used for domestic purposes. The main processes involved are filtration and sedimentation, which both remove solids, chlorination, which will kill bacteria, and the use of carbon to remove taste and odours. Don't forget to check out all our other fantastic revision resources here.
Okay, so that's the tutorial on water treatment. Filtration, sedimentation, chlorination, and use of carbon. 4th step in water treatment: filtration, you filter the water. Sedimentation, okay, the particles fall due to gravity to the bottom of the tank and settled at the bottom. After sedimentation, chlorination, we add chlorine to kill the bacteria. After chlorine, use of carbon, okay, to remove odor and smell from the water. Okay, so this is the first step in water treatment. And we say water supply. Water is taken from the rivers, reservoirs, underground sources for this purpose of purification, right? A rock that stores water is known as aquifer. We mentioned this. Now let's talk about the water treatment itself. But we've summarized them already. The treated water contains soluble and insoluble impurity. So we need to get rid of this impurity because they're not suitable for consumption. Insoluble impurity includes soil, pieces of plants, and other organic matters, like solid things. Insoluble means solid things, things that didn't dissolve in the water. That's what we mean by insoluble impurity. Impurity that did not dissolve in the water. Now, we have soluble impurity, the one that dissolves in the water and that you don't see physically. Okay, soluble impurity include dissolved calcium, dissolved magnesium, dissolved metal compound, and inorganic pollutants. Okay, water is pumped into the sedimentation tank where the water is allowed to stand for a few hours, right? So why do we allow the water to stand for a few hours? So that it can settle, right? So that the water can settle. Mud, sand, and other particles will fall to the bottom, you see, so it can settle. Other things like mud and sand and other particles will fall to the bottom of the tank due to gravity and form a layer of sediment. So this process, second process, is called sedimentation. Remember, the first process is filtration. The second process is sedimentation. The third process, you say filtration is the process used to remove the smaller particles by passing the water through the layers of sands and gravel filters that traps the solid particles, and they can remove all of this. Now, water is also passed through the carbon, okay, in the form of charcoal, to remove the taste and the odors. We don't want taste because water is tasteless, and water is colorless, and water is odorless. To remove the taste and the odor from the water. Okay, bacteria and other microorganisms are too small to be trapped by the filter, so the chlorination is used to kill the bacteria. Now let's take a look at this treatment. Cholera and typhoid are examples of bacterial diseases which can arise from the consumption of untreated water. So when you consume water that is not treated, when you drink it impure water, one of the big problems that can result, or disease that can result from this, is cholera. You can have cholera, you can have typhoid fever, as it were. In many of the third world nations, in Asia, in Africa, in South America, many of these third world nations, they still have this problem of impure water. Not many countries have been able to solve the water problem. So first of all, water is pumped into a tank, okay? And in doing that, we have to filter the water as we pump into the tank, right? Screen traps large materials like the paper and sticks. So we have to filter them here. We have to screen them and remove them and have the normal water, the quartz filter. Okay, after that, we pour the water here. Then the solid substances that did not dissolve or that were not able to be filtered off will settle at the bottom of the water as sediment. Okay, they will fall due to gravity and settle at the bottom as sediment. Then after that, we do chlorination, right? After that, we do chlorination. We add chlorine to kill the bacteria. And then we can get water. The water we have, we use carbon from a charcoal to remove the odorless and taste, to make it odorless and tasteless. And such water can be sent to our home. So this is the method that is being used to purify water. Okay, next we will take fertilizer in our next class. Okay, in our next class, we will take fertilizer in this chapter. So thank you for joining this class.